Hello, Crafting Redstone here, and today we're going to look at binary decoders. So, what
Let's get
binary
started.
decoders basically do, they take a binary number, so like 1001 or something like that, and what they do with that is they convert it into the decimal system, so 0 to 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a quick example of a basic binary decoder. This is a 4-bit binary decoder. And what we've got here is the two numbers, currently 0 and 0 because they're both off. And here we have the output, so we have 0, 1, 2, 3. Now all the outputs we can have for this. So if we make a binary number of 1, so that is 0, 1, we get the output 1. If we make a binary number of 2, we get the decimal number of 2. And the binary number is 1, 0, for 2. If you don't know what binary is, check out the last video. I do a quick explanation on how binary works and why it is used. And finally, if we wanted to make a 3, we do 1 1, what is 3, and we'll have the output 3. So this is a basic binary decoder. Now, let's have a look at how these are made. These binary coders use AND and NAND gates. But unlike the last video, these AND and NAND gates are vertical ones, so they can all fit into one block, like this. So here we've got a NAND gate. This is because on this, when we've got a redstone signal going under the block, when the piston is up, we've got redstone wire to lead to the lamp. But when the pistons are down, we've got a repeater, what takes the signal, and then puts it through to the lamp. Whereas the redstone wire isn't powered because it's not connected to this. So these are basic AND and NAND gates. So if this was a binary number, such as 0 and 1, would have the output. If it's 0, oh sorry, this quite often happens with a lot of these, because if you didn't know, pistons can get powered when there is no power going to them. This is a big problem in Redstone, but yeah, that's what that was. So if it's on, I mean off even, so that would be a 0. Let's get rid of that. If that was a 0, then would have the 0 output. If we had a 1, so on, would have a 1 output. And that's basically what it is. It's just an AND and an AND gate. So the NAND gate, as I said, I'll say one more time. How it works is we've got these pistons up here. They push down, and when that piston covers this block here, the redstone signal can't get through. So the NAND gate will not work because one's on and the other one is on too. So that one will not work. So the reason why this is an AND gate, an AND gate, sorry, rather than NAND gate, is because we've got this redstone wire here. If we replace that with a repeater, then it turns into an AND gate, and that is basically the difference. That's how you make them. So let's take as I said a minute ago, the AND gate has a repeater after the piston when it goes down. So it goes repeater, redstone wire, one block down, redstone wire, and a repeater. That is an AND gate with the piston on top. If you wanted an AND gate, as I said, it would be a repeater, redstone wire, one block down with a redstone wire on top, and another redstone wire, and that is an AND gate. So as you can see, if that is on, that is one input to the AND gate, the red, and then this is another input back here to the AND or NAND gate here. So that is the input 2, and then here is the output. So as you can see, when both of them are down, it's 1, and if both of them are up, it is 0. And this is the basics of how these AND and NAND binary decoders work. There is ones what don't use pistons, but I'm not going to feature those in this video because pistons are basically the easiest ones to make. So let's have a look at another type. Now let's take a look at a binary decoder what is much bigger than this one back here. This binary decoder can do 64 outputs. So as I said, binary decoders can be as big as you want them to be. It just depends, what you're prepared to make. So this is one I made for a previous project. I use this for displaying the actual decimal numbers rather than the binary numbers, because it's just easier to read, obviously, know exactly what it is, rather than you getting the output of like just a binary number. So what this one works, as you can see, at the moment, none of the input binary numbers are on. So this means it's a 0. So you've got 0 lit up here, and this light lit up here. So that equals that. This is the units, and this is the tens column. So here we've got 0 plus 0 equals 0. And you can see none of the other lights lit up. But for example, if we were going to make a number such as, let's make 16 plus 8, what is 24 obviously, and basically what that's going to do is going to take a minute, and we're going to have an output here. So as you can see, that says 4 in the units column, so 4 plus 2, what is this number here, as you can see, plus 20 equals 24. So this is just one big binary decoder I made. It works exactly the same as the others. It has NAND and AND gates, as you can see, repeat in some places, and redstone wires in others. The reason why it's got these repeaters down the middle is because the redstone signal runs out if it's got no repeaters previously. So, for example, if I didn't have that redstone wire, when it's on 0, the signal wouldn't go all the way through. I mean repeater, sorry, if I said redstone wire. So this works exactly the same. The reason why it's got slime blocks is because we'd have lots and lots of pistons all going down, and that would have quite a lot of lag. So with this slime block, it just does a bunch of them at a time. So that's the only reason for having those. As I said, this can have 64 different bits of information, because we've got 32 is the max number of binary numbers what can go into it. And so we have 0 through to 64, well 63 even, sorry. So if we had all of these on, it would be 63. But because we've got 0 as well, we've got 64 different bits of information. And this just works exactly the same as the smaller ones, as I said. It's just a lot bigger and can handle bigger binary numbers. So as you can see, 3, and you can see the top one is little, what would be 6. So 63. Just to clarify quickly, if the number, such as, I don't know, if we were using 10, so 1010, if you wanted to put that in a binary decoder, if it had a 1, you'd use an AND gate, and if it had a 0, it would use a NAND gate. So for 10, it would go AND, NAND, and NAND, and then that's what you'd put into this. So in that combination, you'd put them into here with the repeat and the redstone wire. Also, I just want to show you, so if we had a binary number such as 1011, what you'd put into the decoder would be AND, NAND, and when making the decoder. So that answer would come out as 19. And now you're thinking, alright, it's great that we know how binary decoders work, but what do we actually use them for? So if we have a look over here, decoders are very important in computers for such things as information storage. On computers, decoders tell you which line to save it to and read data from. So we'll take a quick look at this with this here. As I said, binary decoders are mainly used to store data to a certain location. So if we had 64 places to store data, we'd put in the binary number of the relevant place we need to store them to, and then this would give us the correct output, and then allow us to store it in the right place. So this is a basic one. This has 2 places to store data, A and B, and it has 2 outputs, depending on where they go. 1 input to write the data to, so if we wanted it to have a 1, we'd push the lever down, and it would store it to the relevant place. And then we have a place, this is the binary decoder, what determines the place we want to store them to. So, if we had place A down, so that would be this one here, because the piston is pushed down, allowing the current to flow through and store it to this place here. If we then push this lever down, like so, it would store it to place A, the memory cell A, and then come back here, and then light up this output. If we want to store it in place B, oh sorry, I need to leave that down even, and then we push this just to reset it, and then now we want to save it to place B, it would highlight this lamp because we've stored it to a different place. And this is the main use, as I said, for binary decoders. There is many other uses for them, but mainly it's using computing to determine where to read and store data to. So if you want more videos like this, please don't forget to like and subscribe. It really helps, because I did spend a lot of time on making this tutorial, and it would just really help out. So thanks for watching, I hope you've enjoyed. See you next time from Crafting Redstone.